Maybe this is the first course of your core engineering. So what I will do is, I will take you into first introduction to the instrumentation engineering course. Then I will move to the course. Okay, that will be better. Let us see the block diagram of a closed loop system. Usually this is called as automatic system. Agree? Okay.
Yes, sir.
Yeah, it looks something like this. There is something called as process on which we want to perform automation operation. Because we all know that there is no automation without sensors. Agree?
Yes, sir.
I'm sorry, there was important call to be attended. Okay. So I was telling you that there is something called as, in any closed system, called as process. Okay. Which working we want to get it done automatically, right? So for that, the minimum thing needed is a series of sensors. So this block is something also called as feedback. What is this called? Feedback. Yeah. Here we have a mechanism to compare these feedback values with a preset values. So this preset value is called as set points, right? This preset values is called as set point. So the feedback value are compared with the static values, okay, which is actually our benchmark, right? Which are actually our benchmark. If any difference between these two is observed, is called as error. Do you agree with this?
Yes.
Yeah. Now moving further. There is a component of the closed loop system called as controller. This is very, very important. Okay, most of your subject belongs to this controller. There are, okay, we'll get back to the next about the entire closed loop system one by one. Okay, controller. I was telling you that the important component in the closed loop system is called as controller. What is the job of this controller? Can you guess?
Modulating the values.
Yeah, you are very near to the correct answer. Can anybody else guess?
To control the system, sir. Flow of
Yeah,
anything.
you are also very near to the answer. Any more clarification?
It will cancel those errors.
Yeah, let us see this thing very precisely with a consideration of an example. Typically, suppose this particular process is our air conditioning system, AC system, right? Let the parameter of AC system which we want to control, approximately I'm telling, suppose is let temperature. Agree or not?
Yes, sir.
Yes, sir.
Yes,
There
sir.
will be a few more parameters, but I'm considering only one for now, for simplicity. So we have a sensor which measures the temperature. So we can consider the example of sensor to be temperature sensor, right? Suppose this temperature sensor is reading the value in the present iteration as say 30 degree, and we have set our air conditioning system set point, usually we do with the help of our remote, right, as 26 degree, right? So observed value is 30 degree, set value is 26 degree. Any difference are you able to see?
Yes, sir.
Yes, sir.
Okay, what is that value?
4 degrees.
-4 degree, that is important. -4 degree is the error value observed. What should be the value of, what should be the role of this controller? Its role is to make this negative error null, right?
Positive. Null. 0.
Yeah, its role is to make this negative value null or make it 0, ideally. So in doing this thing, it create an output called as control action. We usually call it to be control action. That control action is not having direct influence on the process. Instead, it is having influence on another element called as FCE. It is called as final control element. In the present case, this final control element is nothing but the excitation to the compressor, right? Agree or not?
Yes, sir.
The excitation to compressor and the excitation to a fan. So what this control action do is continue the action that is supplied to compressor as well as fan, so that the surrounding temperature of this AC system gets down, and next iteration the red value will be smaller than the last case. If suppose this observed to be a value which is equal to or smaller than the set value, then the control action will not be giving action to compressor and fan. Instead, what it will do is it will stop giving excitation to compressor but continue giving excitation to fan, because we want to maintain the temperature. So this is how a closed loop system work, and this is how an air conditioning system work. I hope you all understand this thing. Any comment or any doubts you people have are highly encouraged to be accepted.
Sir, once again, can you repeat controller and final control element, sir?
Sure, sure.
We are getting confused in that.
No problem. No, I will do that. I will do that. Let us consider a simple case. On off. Okay. What I will do is, Instead of explaining directly to the automatic mechanism of controlling, I will take the example of manual control. Let us suppose that instead of a machine, a man is standing over here. Man is having in his hand temperature sensor, with the help of which he is measuring the temperature. And he observed that the measured value of temperature is 30 degrees. And he is having in his hand a remote with the help of which he can continue giving excitation to compressor as well as fan. So what he will do is he will continue giving excitation to compressor as well as fan. I'm talking about air conditioning system. Hope you all know the working of air conditioning system.
Yes, sir.
So what are the excitation given to air conditioning system? In order to maintain the cooling, there are two things present in air conditioning system. One is compressor, another one fan. Yes,
Yes,
no?
sir. Yes, sir.
For cooling purpose, fast cooling purpose, we take the help of compressor. And for constant cooling purpose, we take the help of
Fan.
fan. This is for constant cooling purpose, and that is for fast cooling purpose. So he will be giving excitation to both compressor as well as fan. Suppose after few minutes, he observed that with the help of his handheld temperature sensor, the value is coming to be 26 degree or even lesser than that. Then what he will do is with the help of his remote, he make the compressor off and continue the fan. And like that, he will be doing the operation and maintaining the temperature of the room or office to be constant or near to 26 degree. Is that clear? Then I will move to the
Yes,
operation.
sir.
Okay, then let us consider this operation. Let us consider this operation with the help of our controller. Machine-made controller, right? Machine-made controller. This machine-made controller is actually implementing the arithmetic equation. It is nothing but it's like a CPU. It's like what? A central processing unit or a computer. It is actually executing an arithmetic equation. So I am considering a simple arithmetic equation. The output of controller is suppose equal to Kp time the error value, or I will write like this. The output of controller is equal to Kp time error, or output is directly proportional to error. Can I write like this?
Yes, sir.
Yeah. I will remove the proportionality. Remove the proportionality and write output is equal to some constant Kp times error. So this arithmetic equation is actually a value which is directly proportional to the error value. In the present case, suppose the Kp value is, let us say it is Kp only, so minus 4 times Kp. Yes, no?
Yes, sir.
Yeah,
Yes,
minus 4 times Kp. So it means that this is actually some negative value. Then this final control element is nothing but in this particular case. Now, try to consider a real-time case. In this case, in air conditioning system, the final control element is nothing but the actuator, or more precisely, it is relay. It is what? relay. This relay get energized if observed value is negative, right? This relay get energized if observed value is negative. And this relay is actually, मैं अभी और अच्छे से समझाऊंगा. You see this thing? This is relay controlling compressor. We have one more relay, both in final control element. This is actually controlling excitation to fan. If observed input to final control element is negative, then what happened? Both relays get energized. If observed value is positive, only one relay get energized. Hope you understand now.
Yes,
Okay.
sir.
Maybe you don't know what is the meaning of relay. Assume that relay are nothing but switches. What is relay? For now, you assume that relays are nothing but switches. But this is specialized switch. What is this? Specialized switch. This is actually called as electromechanical switch. Remember, I am discussing only introduction to your engineering. There is no relation of this with your course. Don't think that if you don't understand some of the thing of this thing, then you don't understand your course. There is absolutely no relation between this introduction and your course. Okay, fully. Anyhow, there is some relation to which I will come little later. Okay, some of you asking me a question, you have some doubt about controller and final control element. That's why I am going into deeper of this particular explanation. Hope you all understand. You see, I told you the controller are nothing but it is actually a central processing unit which is executing an arithmetic equation. The equation is something like this. The output of controller is directly proportional to error. If we remove the proportionality constant, it is equal to Kp times of error. In the present case, it will be equal to -4 times Kp. Then move on further. What I told you is the output of the controller, we all know that is actually applied to the relay. So the computer after observing any negative value from the output of this arithmetic equation, make both relay on so that compressor as well as fan become on. If suppose it observe the calculation to be positive, then it may, meaning who make? The computer make only one relay on. That is nothing but relay to fan,
Fan.
not compressor. Like this, it will do or implement the automation operation. Hope it is clear to everybody.
Yes, sir.
Yeah. अभी इधर देखिए, your entire engineering is based on this particular block diagram. Your entire engineering, all the courses are based on this particular block diagram. There are a few courses which discuss about these sensors. There are a few courses which discuss about this process. There are a few courses which discuss about this final control element. There are a few courses which discuss about this controller. And there are a few courses which discuss about the optimization of these systems. So like that, your courses are designed. Hope you understand your engineering with the help of this block diagram.
Yes, sir.
Yeah. Now, let us consider the part of this block diagram which is discussing our course. Can you guess? Our course name is
Energy, sir. Controlling energy.
Yeah, our course name is Transducer Engineering. It is actually trying to cover the sensor component of the closed loop system, right? Sensor component of the closed loop system. So this particular course belongs to this part of your closed loop system. Hope you understand.
Yes, sir.
Yeah.
Yes, sir.
Now, introduction to our course. YTE or Y sensors. Any idea from your side? Why transducer? Why sensors?
They are a necessary uh, element for automation.
Yeah, exactly. Correct answer. It is necessary element for automation. Which automation? Industrial automation. Necessary element of industrial automation, right? That is the reason we are discussing sensors in our instrumentation engineering. Okay, imagine a world of automation without having sensors. So it will be not possible. There will be no possibility of automation without having sensors. Okay, now let us move a step further and look into the latest emerging technologies. IoT, augmented reality, huh? AI based system, which is called as CPS. Okay, I will restrict to these three emerging technologies. Let us see these three latest technologies and try to observe the use of sensors in these three cases. So can I proceed for that?
Yes, sir.
IoT. IoT. The first module of IoT is nothing but sensor. This is the first module of IoT. What is this IoT? Internet of Things. You are trying to connect anything to internet. So in order to connect anything to internet, definitely there will be a use of sensor in that. Without that, there is no concept of connecting thing to internet. Remember this. I'm considering an example of wireless sensor network. Can you please pronounce this?
Wireless sensor network.
Sensor network. A network in which a network which connect sensors which are distributed at different places. Okay, so it is actually called as node. Suppose this is node 1, node 2. This is nothing but one device belonging to Internet of Things category. They are actually distributed at different places. Example, this node is suppose fire detectors, and they are detecting the fire triggered in the forest. Right? Forest. These nodes are nothing but fire detectors, which are placed at different places in forests. Do you think that they are necessary to address?
Uh,
To
Yes,
address?
sir.
Yeah. You see, when temperature increases, automatically fire triggers at different places in the jungle. Right? If suppose we have a mechanism to localize that particular problem, then immediately what can we do is we send some helicopter, or we send somebody to that particular place and then try to make that fire off. If suppose we don't do this thing, then it starts spreading and cover the entire jungle, and also make our city also or villages also to get disturbed. You see, in most of the European countries, this is actually a major problem. Even this is started in our India, right? For
yes,
that,
sir.
what people do is they connect these fire detecting system, okay, at different places in jungle, and all are connected with a network, and that is called as the wireless sensor network application. Okay, in that I'm not going to explain you how this work. I'm trying to explain you what is the use of sensor in that.
Yes, sir.
Definitely you find a defined a certain use of sensor is available in almost all things connected with internet. So that is the reason I'm telling that the first module of IoT is nothing but a sensor. Agree or not?
Yes, sir. Agree.
Yeah,
Yes, sir.
yeah, good. You can consider enormous amount of applications of IoT in which there is a presence of sensor. Everybody can guarantee that there is a sensor in there is a sensor in every IoT device. Okay, next, augmented reality. Yeah, this is again a hottest topic. Are anybody aware of this thing?
Oh, yes, sir.
Yeah, augmented reality. Uh, a different variant of this is virtual reality. Virtual reality. Lot of applications of this thing is there in industry. You see, sometimes what happens is, suppose a doctor is doing about sometimes what happens is, suppose we are doing the measurement, okay, we are doing the measurement, and then we want to have a 3D look of that particular measurement, so that we can precisely sense the dimension and accordingly initiate some action. In that case, what we need to do is we need to actually augment the physical dimension. That is called as augmented reality. आमिर खान का वो ad देखिए आप लोग, सैमसंग का आता देखिए. Have you seen that? He will be pressing on the screen, on the air in fact, or on the screen other than the mobile phone, and that is actually getting connected to the mobile phone of Samsung. Have you seen that? Let us show you augmented reality example.
Hey everyone, today we're going to talk about the mind-blowing technology which is revolutionizing the present and the future. That is none other than immersive technologies. Immersive technologies comprising of virtual reality, augmented reality, and mixed reality are amongst the fastest growing and fascinating technologies today. So what is immersive technology? To put it in a nutshell, immersive technologies create or extend reality, and this is done by immersing the user in a digital environment having applications in different domains. This technology is gaining momentum with every passing day and hour, transforming and helping us reimagine the future. Let's start with virtual reality. Virtual reality uses VR headsets to create a simulated environment and helps an individual to immerse into it to experience an entirely different reality. However, the historical journey of virtual reality began back in the 1800s. This marvelous idea has been evolving from the time practical photography came into existence. Morton Heilig invented the first VR device called Sensorama in 1957. His multimedia device, the Sensorama, is considered one of the earliest VR systems. However, the term virtual reality was coined later by Jaron Lanier in 1987 during his intense research on this evolving technology. A lot of companies are investing billions of dollars in the VR sector. Some of the best VR products are Oculus Quest, Nintendo Labo VR Kit, Sony PlayStation VR, Lenovo Mirage, and many more. These gadgets enable an individual to immerse in a digital environment to experience a world which is different from reality. You might think VR is all about gaming, isn't it? But the potential of VR doesn't stop there. It is revolutionizing many other industries like education, military, medicine, and sports, to name a few. Here are some examples of VR in real life. Class VR is an innovative new concept in the educational industry which uses VR tech to raise engagement and knowledge retention for students of all ages.
Skip this thing and come to augmented reality.
Reality, helping us with Pokemon using Pokemon Go or fix any furniture using the IKEA app. These are made possible by the technology called augmented reality. Augmented reality has seen raging in popularity over the past few years, and the revolution is not stopping anytime soon. AR is giving brands the power to promote.
एक सेकंड ठहरो, इधर देखो आप, are able to see? जैसा ही आप यहाँ पहुँचेंगे, the price will be can be seen over here. This screen is not earlier available. The moment a man reaches this particular place, this screen will be seen over here. This is called as augmented reality. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
अभी मैं आगे और नहीं जाऊंगा because it eat lot of time. You can see this thing later. So what I want to tell you is, with both augmented reality and virtual reality, a sensor, sophisticated sensor is a part of both, right? Sensor is doing the measuring of the data which is available over there, and with the help of the mirrors that will be displayed on some screen or something like that. In case of augmented reality, you have seen virtual reality, it is used in gamings, right? So I don't want to go into that thing. So I will restrict myself to tell you the importance of augmented reality. Hope you all understand, and hope you all convinced that sensor is a part of both technology,
Yes.
augmented as well as virtual reality. Okay, let us consider the last one. ये थोड़ा interesting है and very useful also. That is nothing but AI based system. AI based system. What is AI based system? The actual name of AI based system is this one. Cyber physical system. It is actually based on 5C protocol. Okay, can you please pronounce this? AI based system is called as what?
CPS.
CPS. CPS means what?
Cyber
Physical
physical system.
System.
system. It is based on which protocol?
5C protocol.
5C protocol.
5C protocol. Very nice. अब इधर देखिए, what is this first C? First C of this 5C protocol is nothing but conversion. First C of this protocol is nothing but conversion. Okay. What is this conversion? मैं बोल रहा हूं आपको, none of the system exists in nature which work without sensor. People speak about data. From where we can get data? Who is the creator of data?
Sensor.
Yes. Allahu Akbar. Kalma padna pata. Creator is Almighty, and from where we can get data? We can get data from sensor. Sensor is a source of data. Right? Agree?
Yes,
Sir,
sir.
sensors are used to measure the source of data, right?
नहीं जी बाबा, यहीं से डेटा मिलेंगे ना. बिल्कुल
Sir,
बात सही है आपकी. Sensor is a mean with the help of which we can do measurement.
yes,
But
sir.
that itself data. That itself data. समझ गए बात आप? That
Yes,
itself.
sir.
अभी समझ जाइए, मुझे मालूम करने का है. I want to know the carbon monoxide content of the entire city and from different places.
Sir, when we see in a single example, sir, like when we are measuring the fever of a person, yes, the measuring is sensor, no, sir? Like the thermometer in this case is sensor, right? And the data present in the body, no, sir? The heat which is present in the body, it is known as data. And when we are using thermometer to measure that data,
या आपकी बात सही है, बिल्कुल सही है. बट सिस्टम थिंक दैट. अभी देखिए, मैं आपको ये बोलता हूँ, डेटा जो है बॉडी के पास से ही आ रहा है. फैसिलिटेट कौन कर रहा है वो डेटा को आने के लिए?
Sensor.
समझ गए बात? अब देखिए, इतनी बारीक बहनी से देखे तो बहुत प्रॉब्लम होता. आई एग्री विथ यू, टोटली एग्री विथ यू, बट वी नीड टू many situation in many situation we need to approximate the things. So in general we say that the source from where we get data is sensor. अब देखिए, जंगल की आग का टेम्परेचर ले रहे हैं आप, वही सोर्स है डेटा का, लेकिन फैसिलिटेट कौन कर रहा है आपको? द सेंसर. पोल्यूशन कंटेंट आपको मेजर करना है, तो पोल्यूशन कंटेंट तो वो जगह वाला ही तो सोर्स है ना वहां. अब who is facilitating to get that data? The sensor. So in general we can say that from different sensors we can get data. Okay, so data is needed for all AI based system. The first part of AI based system is conversion. Conversion is nothing but sensing the data from the physical world and converting into a value which can be processed. Hope you all understand.
Yes, sir.
Yes, sir.
Okay, conversion. First is actually creation. Second one, conversion. Third is cognition. Fourth and fifth, both in short we can say that use for configuration. They can use for configuration. Okay, let us not go into third C, fourth C, fifth C. Let us restrict ourselves to first C and second C. These two together make a course called as TE, Transducer Engineering. The transducer engineering covers the creation of data and conversion of data from that form into another form. Hope you all understand.
yes, sir.
Yes, sir.
Okay. That's all from today's class. And can you please give your attendance? What is today? Today is 8. 4, 20, 21. Attendance. Roll number 1 to 10.
Roll number 2 present, sir.
This batch is 19 batch or 20 batch?
19, sir.
19.
Okay, 19 batch. So 160419739. Roll number 1. Okay. चलिए बोलिए next. Up to 10. Up to 10.
3. 3 present, sir.
Continue up to 10, please.
4 also, sir.
4, then
5. Roll number 5 present, sir.
up to 10, please continue.
6 present, sir.
Okay. Continue.
Sir,
Up to 10. Continue up to 10.
10 present, sir.
Okay. Next.
9 present.
9 is also present. Okay. 9, 10. Okay.
11 present, sir.
Okay. Up to 20, please continue fast.
14 present, sir.
Okay.
Sir, 13, sir.
13 is also present.
Sir,
Okay.
19 present, sir.
Okay. After that, 19.
Present. 16 present, sir.
18 present, sir.
Order में बोलो ना बाबा.
17. 17.
16, sir.
हाँ, order में बोलिए. Okay. Okay.
18, sir.
Okay. 16, 17, 18, 19. After that, continue up to 30.
22 present, sir.
Okay.
25 present, sir.
20,
5.
25. Then, okay, 31 to 40. Okay, 41 to 50.
32 present, sir.
30,
32.
32. Then,
38, sir.
31 present, sir.
31 present. Then,
35, sir.
35.
31 present, sir.
Okay, 31, 30,
38, sir.
35, 34, 38. Continue, please, fast.
39, sir.
39. Continue, fast. Up to 50.
41
present, sir.
41, 48. That's it.
50, sir.
50,
Sir, 43 present.
43 is also present. Okay. Continue, please. Okay. After up to 60,
51.
51,
59.
6.
59, 56 is also present.
306.
Okay, 306,
301, sir.
301,
307, sir.
307,
sir. 305, sir.
302,
sir.
302. Okay, anybody else? Any extra? Okay, that's all from today's class. Thank you for joining.